Welcome to another video. In today's video we are going to solve task scheduler problem from the Leetcode. In this problem they will give an array of characters where each character represents a task. So we need to find out what is the minimum amount of time a CPU takes to execute all those tasks. So while executing the task there is also a cooldown period which is represented by n. So in the first example that n is 2. That means if we are choosing a task, we cannot choose the same task again for another 2 seconds. So if you observe this first explanation, so the first task they have chosen as A, and after A they have chosen B, and here they are not choosing any A or B task because n is 2. That means there should be a time units of 2 gap between two same tasks. So that is why CPU is idle here. Here they are able to choose A, not B, because there is a time unit that has been passed from A to till this A. There are 2 gaps. So that is the overall requirements of the problem. One way to solve this problem is we can make use of we can count all the tasks, and by intuition in the task which has more count, that means in this example A is also 3, B is also 3, but if any task has more number of letters in the given array, then that means that task should be given priority. So we will give the task priority, and once we execute that task should be put into a waiting list, because we should not execute the same task again till that cooldown period. So once again we will check what are all the pending task list, and once again if there is any task then we will take that task and execute it. Otherwise we will put the CPU in idle mode. So once I explain these things with an example, it becomes very clear to you. Let's discuss about how we are going to solve this problem. So let us consider this example. Let's say they have given a task list A, 2 B's and a C, and n is 2. So this means this is the cooling period, and between two same tasks we need to have this at least 2 units of cooling time. So this is the requirement. So how we are going to solve this problem is, first we are going to get a count of all the tasks. So we will get A is present 4 times, and B is present 2 times, and C is present 1 time. So once we get this count, then we can put them inside a ready queue. So this ready queue will be a priority queue which is going to hold all the task counts. So we don't have to store this task name, it is irrelevant. So only thing is we don't have to execute the same task within that cooling period. So once we put these task counts into this ready queue looks something like this. So there will be 4, 2 and 1, and another queue we are going to maintain is waiting queue. So initially this will be empty. So from the ready queue we will start taking the task from the front. So once we execute this 4, let's say we are at time 0 and we execute this task. At time 1 we are going to execute this task. So at time 1, once we execute that 4, that becomes 3. Only thing is we cannot execute this 3 until t equals to 3. So what we are going to do is we will put it inside a waiting queue. So we will put the task count remaining, that is 3, along with at what time it becomes available. So it becomes available at t equals to 1 plus 2, that will be 3. So once we put it in waiting queue, then since we have already removed this 4, our ready queue will look something like this. So now we will take the 2. So at time unit 2 we will take this task, that is 2, and we will execute it. So once we execute it, it becomes 1. So we cannot execute till this cooling period. So we will put remaining count, that is 1, and at what time this becomes available. This becomes available at time equals to t. Now the time is 2. 2 plus 2 will be 4. So at the end of executing the task, we will check the waiting queue, whether we will check this waiting queue whether some task became available. If it becomes available, we will put it into this ready queue. So now we are going to our time becomes 3. At time equals to 3, so our ready queue has only this 1. So after executing 1, it becomes 0. So once we finish a particular task, we don't have to put it in the waiting queue. So this will not go to our waiting queue. So it becomes 0 and it completes there. So but at time equals to 3, this waiting task, which initially we put it when we execute this 4, this becomes available because this is the time. Now at time 3 we are saying it becomes available, and now the time is 3. So we will move this task to our ready queue. So our ready queue looks something like this at time equals to 3. It gets modified here. So our 3 once again comes here, and 3 will be the only task which will be present. So our waiting queue will look something like this. There will be only one entry. So at t equals to 4, once again we will check the ready queue. So something is present. So we are going to take that and we are going to execute it, and once again we will move it to waiting queue because of the cooling period. So this is the approach that we are going to take in order to solve this problem. So if there are no tasks in the ready queue, then our CPU will be idle. Only thing we have to focus is we will be keep on incrementing this time, and once this ready queue and waiting queue becomes entirely empty, then we know that all the tasks are finished. At that time we will return t. So I'm not going to go through this entire solution, but this is the overall approach that we are going to follow. Let's implement the same solution that we have discussed here. So the first step is getting this task count. So we are going to declare if you observe the constraint, all the tasks which are present in the task list will be English uppercase letters. So we can easily map that to from 0 to, since there are 26 characters, we can map it to 0 to 25. So initially we are going to declare a counter which will be, let's say, vector int, and I'm going to call this as task count, and it will be of size 26, and all the values will be 0 initially. So for int I equals to 0, I less than task.size I plus plus. So what we are going to do is we are going to get the task count. In order to get the task count, we have to increment that corresponding index. So task count of, so the current letter which will be present in the task will be tasks of I, and if we subtract ASCII value of capital A, then we will get the index which maps to this task count array. Then we are going to increment it by 1. So by the end of this for loop, this task count vector will have all the corresponding task counts. Then we have to put it inside a ready queue. So ready queue will be a priority queue which will hold the task based on the task count. So we are going to declare a priority queue which will store the integer, and we are going to call it ready queue. So then we will go through this task counts for int I equals to 0, I less than 26, I plus plus, and we are going to put task counts into this ready queue. So if it is only greater than 0, if task count of I is greater than 0, then we are going to put the task inside this ready queue. Ready queue dot push. What we are going to push here is the task count of I. So by the end of this for loop, we will have all the task counts inside this ready queue. So only one more thing that we need to declare here is waiting time, this time and this waiting queue. So waiting queue will be just a queue of vectors where each first element represents the pending amount of task, and the next element in that pair represents the at what time the task becomes available. So we are going to declare another queue which is going to store a vector in its each entry, and we are going to name that queue as waiting queue. So then we are going to declare another variable here where, let's say we declare it int time equals to 0, and here what we are going to do is we will check while, let's say we have something in the queue, ready queue dot empty. If this is false, if we have something in the ready queue, or if we have something in waiting queue, if both are not empty, then that means we have some task pending. Then we will check if not ready queue dot empty. If this is the case, then that means we have some task in the ready queue which needs to be executed. So first we will increment the time here, time plus equals to 1, and at time unit 1 what we are going to do at this time unit, either we can choose a task from ready queue. So once we execute that task, we need to check whether we need to put that into waiting queue or not. So we will check if ready queue dot top. So this gets the top entry from this ready queue, and what we should check is after subtracting 1, that is after executing for a time unit, whether that task count is greater than 0 or not. So we execute it for a time unit of 1, and after subtracting 1, if it is greater than 0, then we will move it to waiting queue. So waiting queue dot push, we have to push what is the pending amount of task that is remaining, ready queue dot top -1, and at what time this becomes available again, that will be time plus n. So time represents this current time and n is the cooling period. So once again, if we come in this path, we have to pop that task, ready queue dot pop. So after that, what we are going to do is we will check if not of waiting queue dot empty. This means we have some task in the waiting queue. If waiting queue dot front, This gives the front element, and we need to check at what time it becomes available. So that will be present at index 1. If that is equal to our time, then we should push that to our ready queue. So ready queue dot push waiting queue dot front. That will be the value of task will be present at index 0. So we will push that task back into our ready queue, and we should pop it ready queue dot pop, not ready queue but the waiting queue. Since we removed that task from the waiting queue and moved it to ready queue, we should pop it. And this process continues, and once both the queues become empty, we can return the time. So let us run this program and check whether it passes the initial test cases or not. Okay, I think we have some typos here. Move these declarations inside our function. Let's see, maybe that is related to some class declaration is conflicting. And let's see whether it passes the initial test cases. Okay, now we have some typos we need to fix. Yes, as you can see here, this solution is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. If you are interested in learning more about other data structures and algorithm related problems, consider check out other videos from my channel. Thanks for watching this video.